I'll just introduce myself as follows. Some people know me in the audience. I've been, well, Joe and I go back many, many years and always had these similar and overlapping interests. I came to the UK a number of years ago, and I focus now in this boutique consultancy, Semantic Partners. Particularly, my focus is on ontologies, but there's a lot of second line engineering that has to take place. So getting the ontology is one thing, getting it to speak to the data is a totally different exercise. Especially as we're seeing a trend now, we're seeing two trends. One for clients trying to not allow the data into the graph. So they want virtualized solutions, and a very big push, which is exactly this discussion for whatever you do, AI agents have to be able to work with what you do. So this, though, is kind of introductory, because in chatting to Madison, we kind of felt that we need a common language to act as a springboard, because different people are at different levels of experience and understanding. The second point is, I can't see anybody. So Madison, I'm going to rely on you to interrupt wherever you want to. So let's rather handle the question than leave it till the end, because then it's just a question of managing our time.
Yeah, next time we have to get your second computer next to you with a second login, so you can see all the faces.
So the hypothesis that underlies this talk and what the industry is currently doing is that ontologies reduce AI agent hallucinations. And the way I describe it is the LLMs have been taught to speak a language and translate languages. And the way they've done that is through a vast body of knowledge. So they're okay at language, and because this vast body of knowledge is their training material, they're able to regurgitate quite competently from that body of knowledge. And the way I give the example is, if you wanted an LLM to learn German and you only provided it with Nazi propaganda, it would probably be able to learn German from that, but its conclusions would be somewhat biased and its responses would be somewhat biased. And the hallucinations is a factor of the training material that's been given. The harnesses around it, of course, have been created in such a way that there's a pretense of understanding and a method behind and a way of logically thinking through a problem. But at the very heart, it's just this engine that spews out average language. So what our hypothesis is that when we ground the AI agent in ontologies, we're providing it with structured, consistent, and verifiable content that can then influence the way in which it answers the questions, gives it an ability to check perhaps some of the answers that it's just generating on the fly. That's the area that we want to investigate today. So as we get to that question of what is an ontology, and I divide it up into two areas, and in fact, it's not just my breakdown, but even in ontology schools or philosophy schools, they recognize theoretical ontology and applied ontology. And theoretical ontology is deeply seated in metaphysics and all of that stuff, and applied ontology is as well, but pretends not to. And it's all about the structured representations of concepts and categories and relationships. So often when we're building an ontology, a so-called ontology from data, the best we land up with is a logical data model expressed in RDF. And like, that's interesting, and it is an applied ontology, but you've got to ask some deeper questions about ultimately how useful the thing is. So bear in mind theoretical ontology and applied ontology. And I'm making the point that in practice, whether you want to or not, you're making theoretical choices. I've got two examples of the kind of theoretical choices that exist that you might not obviously think about. This one comes up in many of the industrial settings where we see data, this question of wholes and parts. And I've got three questions that just give you an indication of the flavor of how you actually have an unconscious theory in mind. So, is something greater than the sum of its parts? So you've got a car, and it's got an engine and four wheels and an interior, but it's still a car, and it's got properties that are attracted to it because of its carness, as the ontologists would say, rather than because it's got wheels, because of its parts. And then there's the question, given that the parts comprise the whole, are there properties that the whole has that the parts don't? So a car can go has a capability of, say, going at 200 kilometers an hour. That doesn't really mean that the wheels by themselves have got that same property. And then my classic question is, when you start taking parts away, besides breaking its functionality, at what point does it stop becoming a car? So a car with one wheel missing, is it still a car? Probably. With all the wheels missing? Probably. With all the wheels and the engine missing? Maybe. With the wheels present but the engine missing? And what does it mean to replace the engine? If you're an engine manufacturer, you care about maybe which car it's been in. If you're a car owner, when the engine's not there but it's being replaced, so now you've got your old car with the new engine, it's still your same car. So these deep issues that underlie these most basic notions. The next one that I wanted to talk about is time. And this is a question of identity over time. In my youth, I had curly dark hair, and now I've got somewhat receding, curly light hair. Anyway.
So now we know what you look like when you were young, Simon.
It just makes me laugh, yeah. But this question of identity over time, and there is definitely a school of thought that says Simon, as you see him today, is an aggregation of all of the prior Simons that existed through time. And then to make matters worse, there's a range of possible futures in which Simon does or doesn't exist. So the question there is it Simon, or how do we recognize Simon through the stages of his existence? So that's the question. What makes something the same even if it changes through time? And is that thing one thing or multiple things? And the one that people usually just gloss over, which is quite important, is databases are often in the ETL world, especially in analytics, they tend to be just that snapshot in time. And do you recognize, and how do you recognize those things that are changing in time? So the questions around that, again, that are couched either consciously or unconsciously. I'm going to stop there for a minute or two to see if there are any pressing questions or comments that people want to make.
Simon, I think maybe as a comment from our side is that I think people completely misjudge the complexity of the time dimension. Because if you think about the evolution of a human in any organization's involvement, especially if it's a continuous consumption of, let's say services versus products and the like, a person with or without a house, or a person with or without a vehicle, or a person with or without an account with your business, or a person that engages with you often or does not, all of those could give you a different version of that person that gives you a new kind of almost a perspective of what you need to know about them.
And when you start, finding the things that respond to time, and you find a way in your data of handling it, like whether you use it or not, the flexibility that you get increases enormously. And we'll see in some of these examples that follow what that means and how you go about achieving it. Okay. So the theoretical basis for many ontologies, you're really spoiled for choice. And often people will take this predicate from that ontology, and this predicate from that ontology, and this class from that ontology, and so on. And like, I haven't put schema.org on here because invariably that's where a lot of this just sort of like casual borrowing takes place. So you can't take something like from UFO and from Dolce and necessarily mix and match them. And I'll use the slide also to talk a little bit about upper ontologies. Upper ontologies tend to be very small, and they tend to ground you in the philosophy of what you're doing. So with BFO, basic formal ontology, it's one of the most broadly spread ontologies and ontologies derived from it. Very strong in medical industry and the biosciences industry. The gene ontology is its heritage. But then they've got like these foundries which still all retain the realist metaphysics or the language of things that persist versus events and processes as separate considerations. So again, you're spoiled for choice, but choose them carefully because you can't necessarily mix and match between them. And on this table here, I've just put the top level ontologies, yeah?
Just to check with you then, so they're like looking at psych as almost like trying to encapsulate all of human knowledge compared to BFO that is far more focused. I mean, how do we make reliable decisions, firstly? And secondly, does it make a difference if my agent is aware of the one that I'm using? It will still be reliable.
I think it depends. We do have a placeholder slide to hold that discussion towards the end. It really depends on whether you're letting your agent access the ontology through text or through tooling. And that makes a world of difference, and we'll come to that.
Yes. Humans have trouble reconciling between ontologies, let alone agents. And secondly, I think even if the intelligence was, performance becomes a bit of a consideration because this is not a trivial exercise.
Yeah. That's fair comment. Okay. So I'll move on. So Jay will laugh because we always did consulting stuff together. So as a true consultant, you know that the thing you have to do when you speak to management is come up with a 2x2. So we've come up with the 2x2 on how to understand this.
You always need one of those, don't you, Simon?
But this one actually isn't from us. It's from a chap called Zernach, who's a philosopher, and he was working through the problem of why these ontologies appear to be biased one way or another. And he put down this idea that things are either bound in space or bound in time. And so you're able to craft out this 4x4 from it. And it's a very, very powerful framework on which you can assess many of these top-level ontologies for their positioning. And I'm going to spend some time on each because it's quite instructive, just as it is in terms of the way in which you think about this top level on ontology. Try to put together a thumbnail of how to get a handle on it, and I'll use those thumbnails as we talk about it. So if I start with thing, which most ontologies usually start with at the top, they've got thing, even if it's our thing, always at the top there's thing. But the point about this thing in this sense is that it's bound in space but continuous in time. So bound in space means you're going to see all of me every time you see me. You're not going to see a part of me without me being there unless something bad's happened to me. So you've got these ideas of Fido the dog, the Eiffel Tower, my pencil. There's like a natural understanding that you've got something with material substance usually. That's how you understand it. You also have another one that's reasonably easy, is an event. It takes place usually in a single place and it's bound by time. The example that's not here that I think I took out was a handshake. A handshake is absolutely there and present in space, and it's gone in time. So it's only ever kind of there once. So you never meet it again in that sense. An event is the next one going anti-clockwise. A football match yesterday, sunset, the moon landing, all of those are events. You think French Revolution, the Bronze Age collapse, not fixed to any place. Even if you say, well, the French Revolution was fixed to France, you wouldn't say that people in Paris were saying that's a very bad Paris Revolution we've just had, and the ones in Lyon are going, well, that's a very bad Lyon Revolution we've had. So it's like across broad areas, you'll meet the same idea elsewhere. And that calls that a process, but I much prefer to think of it in these kind of like just to ground your thinking. It's to do with, more to do with time than with space. So the French Revolution is a good one. The Bronze Age is a great example. Anything like that, World War II, you could say is an event, but let's not just split hairs just for now. So those are the three: the thing, the event, process. And the last one is the type. And this one is the one that many ontologies really mess up. Because you think you've got RDF type and our class or RDFS class, and you think that that's enough, but it isn't, because it leads you down a very bad, you'll end up with metaclasses, and you really want to avoid metaclasses. So you've got things like water. The water in my glass is water. The water in my swimming pool is water. The water in the reservoir is water. So it's sort of like forming a pattern. These words, these mass words that we have in English kind of indicate that it's everywhere. Oxygen, water, coal, wood. Those are obvious things that are not in any of the other three categories. But what about something like Beethoven's Fifth Symphony, which if you go to a very poor performance of it, it's still Beethoven's Fifth Symphony, and Beethoven's Fifth Symphony as a pattern has got certain characteristics. It's in so many parts, and it involves usually this collection of instruments, and it's represented by this musical score. So these are things that many ontologies really mess up. This table is important, so I'm going to stop here for questions. I'll come.
We do have a question.
It's perfect timing. Thanks, Simon. Hi, Simon. It's Jess here.
Hello.
So I don't know if I specifically have a question, but it's more of a thought that occurred to me, linked specifically to the ontologies and the way that you're describing it now. So when I was abroad working and traveling, one of the things that came up quite often is to always remember that common sense is not common, right? And it's what you need to like constantly update within yourself is what is the common environment that you're stepping into? What is considered common sense? How do you adapt your own expectations to that in order to understand within that space? So am I right in thinking that in some way, at least, these ontologies are almost teaching that concept of common sense, but within your spectrum of common, so that there is not this like deviation depending on the training data?
Yeah, I think what you've got more is that the philosophers are trying to say, this is how you understand the world. This is the framework by which you understand the world. And when you get into that, what is common, it's really down to some context. Eating etiquette in one setting is totally different to another setting. But this top level of the ontologies, at any rate, and that's what we're talking about here, are the attempt to explain how we can understand at the top level what's going on. And you'll see in the example, which we'll get to shortly, that just having these notions in your head already start pointing you from a design perspective into the kind of way in which you want to deal with the situation that you're faced with and how you want to model it for the practical aspect of implementing something.
Okay, so maybe less about, yeah, the common environments that you come into, but more in how would you teach an alien about the world? If they came in with nothing and they came in with
it's not a bad way of thinking about it. Yes.
But isn't it also, Simon, if you think of in your agentic environment, you always think about context engineering. So that means thinking of a kind of a taxonomy that you need anyway to make sure that your hierarchy of execution, whatever that is going to be, eventually that's going to get your graph to work, is often designed top down. So people use a linguistic view to do that, where a lot of this is to say, well, can I get a realistic perspective of the reality of the world? Because if I think about most of our engagements with our clients are continuous consumption. So that means that if I'm a bank, I actually don't have a concept called a product. Because if I'm selling furniture or I want to do a moon landing or a football match, it's at this moment, at that time, it happened, there's a score, I'm finished. But if I'm a bank and a telecommunications or a gaming or those kind of companies, the only way that I derive value continuously from the engagement is a person interacting with me all the time. So it's not just about the singular event, the fact that you open an account and I issued you a piece of plastic or a virtual card, whatever it might be. That's not, because it's really about, it's like music. You all the time, you have to get a rhythm and the pace and the understanding of that person's engagement with you. And I think, do you think that is easy to model? Because that's, you and I have been debating this forever. So how did you get that? And especially when
let's turn the page over, and I think you'll see an answer. So people who have worked in corporate IT systems area will know what the N+1 problem is, and that consists of, I don't like any of these systems, so I'm going to replace it with a new one. And in doing so, you create the N+1. Well, needless to say, I've got colleagues here who don't like any of these ontologies and want to replace it with a new one. So I'll talk about that for an instance. In looking at the state of things, decided to have a stab at defining a few. I think if you look at BFO, without looking at schematic particular, you would say there's nothing new here because BFO just divide things up in the same way. Things or continuance and eventualities or occurrence. So without schematic particular, we've done nothing. We just like relabeled BFO. But with schematic particular, you're doing something in addition to that. And of course, many other ontologies don't quite make that same distinction. So what we've done here is we've said things that are bound in time, irrespective of whether they're continuous in space or bound in space, are eventualities. And they've got certain modeling features. Things remain things, those we've always understood as like the nouns that exist in our world. And schematic particular, we're going to take a deep dive on because all the other ontologies really get this one badly wrong and land up with metaclasses or other effects that are hard to deal with. So when you talk about an engagement, that engagement is one long eventuality that's made up of many different other eventualities. And on that basis, you can actually name it, deal with it, structure it, analyze it, and you really have this constant stream, as you put it, of eventualities, which you can fragment into whatever time slice you like and whatever place you like. So I would say we would, in your situation, be looking closely at what eventualities mean, how they're structured, and how much reliance you can place on crafting a solution based mainly on eventuality.
Here's a question then. If you take the banking, the telco, the gaming, whatever the example is, can we then declare that the act of, let's say in a bank, the act of the purchase, so the eventuality is quite well defined.
Yes.
But can we then, because what we've been trying to, can we then make an assumption that the reason why a person bought food is because they're nourishing themselves, and if they don't buy food, we can't make an assumption they're not eating. So what we attempt to do is to say, well, if the eventuality, the evidence of the thing, because in this case, the thing is the category of spend of that person that was present in a retail store somewhere in the world, or in an airline, or in a motor car, or putting in gas in a car, whatever they've done, they were present when they spent that money, giving me evidence that that thing in that time, in that space, was accessible, so that you can then extrapolate the eventuality. And then the reverse also apply. So how does that, because that is, I think, a particularly tough thing that we're trying to find a well-defined structure around.
Well, I think what you've got there is some sort of schematic particular, which is a pattern. Let's just for now call it a pattern. They're saying that the average person needs food, and in the eventuality portfolio that I've got for this person, they don't have food. But the average person needs food, so there's your opportunity between the schematic thing and the observed thing.
Yes. So the thing is that how would you then describe eventually the ontology that is going to deal with the eventuality might get the thing to have different properties at a different point in time? And that's what I think.
We'll go on to the next slide.
Perfect.
Okay, so the setting now, I mean, you could have got there quite easily. It's given the clue of Verona that we're going to talk about Romeo and Juliet. But we're going to take the story of Romeo and Juliet through the lens of the framework of eventualities and schematic particulars. In the same way as we spoke about Beethoven's Fifth, we've got Romeo and Juliet, the novel. And it's true of every novel, is that my copy on the shelf that I bought from this store is still Romeo and Juliet. So in a sense, that thing that I hold in my hand is a concrete version of Romeo and Juliet. And it just turns out that it could just as easily have been an eventuality, because the performance at the Globe Theatre on the 25th of January 2019 at 7 p.m., good or bad, is also a concretization of that schematic thing. So that's how the schematic thing turns into the actual thing. So we distinguish between schematic particulars as well as concrete particulars. So then just going back to reinforce the question, you would be able to say there is a set of schematics that describe the average, name the kind of customer you're dealing with, and you can then see how that's being concretized by the evidence that you receive. And it's either going to match your expectations or not. And in that, you'll find those opportunities as we spoke about it. So just think, expectations can be expressed in a schematic particular, whether it's expectations of an event or an actual thing. And then when the reality appears and you record that reality, you've got something to contrast it with. Okay.
It's kind of exactly the case, Simon. So that's spot on. That's kind of how we need to describe the thing versus the eventuality, because you can then get the concretization around the evidence of a time and a place where the person actually did the action. Yes.
Yeah. Okay. So let's move on a smudge. Causality between eventualities. The top level of the ontology, you would find out that there's a predicate, cause is the cause of. And what's here is basically the timeline of the Romeo and Juliet story. The feud is the cause of Mercutio's death, which is the cause of Tybalt's death, which is the cause of Romeo's banishment, which is the cause of the letter being created, which is the cause of his fake suicide, which is the cause of Juliet's death, which is the cause of his death, which is ultimately the cause of the reconciliation. That whole story just told as causality between eventualities. There is a theoretical question that I might just open the mic for 10 seconds and then close it. Could you then conclude that the feud caused the reconciliation? In other words, is this relationship transitive?
Well, isn't that what happens in real life all the time, Simon? People
Yeah.
try to skip the steps to get to the answer, and they just go back to the origin and they say, well, that's where it started. But that's not how the world works, is it?
No, but I think it's one line of contributory causality, but it ignores all sorts of other factors that have also contributed.
But that's
Anyway.
that's the chain event that never gets analyzed or understood because it's too tough for most people to do.
So I think you're right. There are just these two questions that I wanted to raise is that when you're at the top level of the ontology and you recognize that causality exists between eventualities, you've got something powerful. And then I just threw in the party question of is causality transitive? So just in this setting, it looks so odd to say that the cause of the reconciliation was the original feud. But that's just me. Let's look at Mercutio's death, which is, remember, it's an eventuality. And then the things that are around the eventuality also described in the top level ontology, but this death has an affected participant, because the key thing about eventualities is it's got participants and it's got time. So we're looking here at the participants, not so much the question of the time. So the affected person in the eventuality of Mercutio's death is Mercutio himself. The agent is Tybalt, and the instrument is the sword. And with that, you've kind of described enough for Mercutio's death. And you also have its cause as a backward pointer, which in ontologies would often be modeled as an inverse relationship. So the point that we make, that Mercutio, Tybalt, and the sword are all things, ultimately. Persons, natural beings, etc., and then things, and has affected, has agent, has instrument, are all special cases of the relationship between a eventuality and a participant called has participant. And its inverse is participant in. Now, what would this ontology tell our AI? You should get to the same answer, more precise in OWL, by OWL I mean use your graph, than if you just wrote these facts in English and gave it in this context. So that's where I'm starting to see the distinction between, I can just give the ontology as text, as context, which you can, but if you give it the actual graph of the ontology with tooling, you might get a more precise answer more efficiently. So what you can tell the AI is that ontologies participate in eventualities via a relationship is participant in or has a participant. And that means that these can have entities as participants. If you then said to the AI, tell me about Mercutio's death using only the grounded facts, you should expect this reasoning. Mercutio's death is a death, which is an eventuality. And because it's an eventuality, I should expect has participant relationships. And I happen to have found three: an affected relationship, an agent relationship, and an instrument relationship. And I know that Mercutio is a person, which is a thing, which is an entity, and Tybalt is a person, which is a thing, which is an entity, and the sword is a weapon, which is a thing, which is an entity. That you get in all because you've done the work of defining the ontology.
So Simon, how does the knowledge graph then overlap with this? Because won't you have some of this evidence also in the knowledge graph as an overlay? Doesn't that sometimes create a little bit of confusion?
Yeah, there are two deployments that are worth talking about. If you are allowing inference in your knowledge graph, it would be able to do inference and create new facts out of the ontology combined with the data. And the other way is if you had defined shackle rules, you would be able to say, my data conforms to the ontology, therefore the AI, you're good to use that ontology in your reasoning. So there are these two things that you might need to consider.
Because I think what complicates it is if you want to find the pattern of behavior, can you then replace Mercutio, Tybalt, sword with anything else? And will that then still work? Isn't that sometimes the problem we're trying to solve here too, is that we want to be able to, because the knowledge graph will give us the evidence of what the has affected versus has agent and instrument really contained in the world situation where the ontology is the description of that.
Well, more particularly, you'd have come down some tree of eventualities and landed on death, and you'd looked at all the deaths for patterns. So is there a pattern of a repeating instrument or a repeating offender or a kind of victim that you would know about because you've got sort of this idea that to understand this body of knowledge in the knowledge graph, I can be steered by the ontology.
Yes, yes.
Yeah, if I can just jump in, Jay, the ontology provides the meaning to what's in the knowledge graph. The knowledge graph gives you the facts and gives you the instances, but the ontology tells you how to interpret them or the meaning. Yeah. So you can then see that, for example, the agent would be the person responsible, the instrument would be the thing used, and you could replace the instance with something else.
But the problem with that is that then I could have said, has affected relationship with my computer, and the agent has a relationship with the cable, and the instrument was scissors to cut the cable, still achieving this. So that means that by then an agent would still make the same mistake. So that means that your knowledge graph, and actually this is one of the things that Simon, I've calibrated my thinking after our deep conversations about some of this, and that's why I asked the question, is that you still need what a good version of the truth looks like. Otherwise, the ontology cannot function. So you still need a reality of the knowledge graph being truly reflective of what the verbs, the nouns, the adjectives in that world versus the subject, predicate, object in the context of the triples you're going to extract from that over time look like.
Let's just run your example. So there's an eventuality in which the affected is your computer, the agent is you. So the affected is the wire, the agent is you, and the instrument is a pair of scissors. The fact that the wire doesn't trace to person means that if you only had affected people, you'd get a totally different set of data out of your knowledge graph than affected computers, where you would have viruses and other things. So it's just that there's more around you than you think to help you. That's the one thing. The other thing is that the reality in production is that you wouldn't only use has affected, you'd go below that to become more and more precise about what you meant, which one of has affected you actually meant. So you would go down and has affected taxonomy or almost for your domain, explaining what has affected means in your domain.
And I think that is what normally needs to happen, and the key point is production, because you need to because this concept needs to be then applied and then tested. And I think the test can be done by a knowledge graph to show you that it is working, but then you also then need to iterate through the validations that.
Yeah, we've got a whole, the way we do that in the practice is for the domain, we get competency questions, and the kind of mantra we use is, for you to be convincing about this ontology, you need to show me how we're going to answer these competency questions.
Yes.
We've got a process for doing automated tests. So we are quite highly influenced by, of course, the IT world that we work in. And therefore, we do competency questions that are ultimately unit tests. And there's a test suite with it. So there are ways of engineering in such a way that you can keep an eye on these competency questions, the ontology, and the way you're shaping the data. And that kind of forms a 360 iteration cycle. So look, LLMs love text and ontologists love writing text. And so you get a lot of just pure text that's made available to the LLM from which it can generate stuff. For example, an entity is a way of being or modification of one or more other entities, qualifying them or making them be or go in a certain way. Death is an eventuality in which the affected entity ends its existence. Going back to your question, Jay, would mean that you wouldn't be, if you had defined death, you wouldn't necessarily be talking about the death of your computer or the death of the wire. And birth is an eventuality in which the product of the eventuality, be very careful there, because obviously in the birth, you might describe the participant differently, but here it's sort of flagging that the product or any of the sub-properties of product is going to be the eventuality. The entity begins its existence. And the same for its participant in and is affected in. So the point is, you're not spoiled for context text when you provide an LLM with an ontology. The question is, how do you deploy it? And this is the second last slide. As I said, there were early attempts that we were doing that said, just take the text, take it out of the knowledge graph, give it to the LLM as text. And it was somewhat successful, but far more powerful now is to wrap your knowledge graph and your ontology behind an MCP server, giving the agents the tools and the ability to get grounded facts directly and grounded language directly from that environment as a tool rather than just a block of text that goes into. Yeah. So that's what we're looking for, I think, going forward, is the synergy between this richer context but via tooling rather than via text.
So at the moment, our MCP infrastructure can do the bottom-up, top-down, middle layer, but it's still very dependent on the loop that gets created for the job that must be done. So that means that bottom-up typically means you want to make it deterministic. If there's bottom-up, that means that mapping the table in somebody's database that is called C underscore ABC underscore whatever is called customer, and some other place is called customer, and you link it to... Yeah, so how do you link it back to the ontology? At the top, I want to get everybody that spends money with me their details. So that means that it will then know from the ontology that if it's well defined, that what that particular class is and how it relates with various elements will mean, oh, that is called a customer. So the MCP's job, and this is a kind of question more than say, well, how much of the work that gets done in mapping it onto the real world data and the infrastructure from a technological point of view, once it's done, you almost want the agent to retain it in memory permanently and lock it down, because you know that the variability is going to come from the questions, from the, I want to know how many customers have purchased this product over the last month and are likely to default based on the category of the people who operate in this geography, and then tell me which devices they used.
You need, like in this other client, we talk about the business question, the recipe, and the competency question.
Yes. The competency is what you want to get to, right?
Yeah, so the competency questions are directly translated through the ontology to the data, and you can prove that with a rigorous test regime. And you're going to give your MCP tooling that earlier stuff as well, because you've done the work. So then it should be able to work it out by itself to say, given this question, I don't know, rag it or whatever else you like, but come up with